So over the next couple of lessons, we're going to look at straight lines. We're going to look at straight line graphs, how to find the gradient of a straight line, how to plot straight lines if we're given the equation of a straight line, and the equation of a straight line itself being y equals mx plus c. We'll look at that as well. What we're going to do today is we're simply going to look at how we find the gradient of a straight line. Okay, so I'll just start off by explaining what is meant when we talk about the gradient. Gradient is simply the steepness of a line. So when you think about steepness, think of a hill or a slope or a mountain or something of that nature. And obviously when you talk about how steep it is, that's when we talk about the incline. So something that is lying flat would have no gradient, whereas as it gets steeper like that, as in harder to walk up, that's where the steepness increases. Okay. When we deal specifically with straight lines, if we would have a line on the page like this going up way, this is known as a positive gradient, and a line going down the way like this is a negative gradient. So because today we're actually going to be looking at the straight lines, it's simply a case of recognizing whether it's positive or do you need to put a minus in front of your answer. Okay. So we'll look at some of the examples where we've been given straight lines. I've been asked simply with the straight lines given and being drawn accurately to find the gradient. Okay, the gradient of a straight line is given by what's known as the vertical distance over the horizontal distance, and that'll become more clear what that means when I show you how to do it by picking 2 points in the line. So this is the line AB. It's called the line AB because it's connected by the points A and B being opposite ends of the line. And what you're expected to do to find the gradient, we need to pick 2 points on the line. Now, I say 2 points on the line, it could be any 2 points, but you want to pick 2 that fall exactly on the cross section of a set of squares, like here or here or here. It doesn't matter what 2 you pick, and I'm going to demonstrate why it doesn't matter as long as you pick an exact point. Don't pick a random place such as this, like in the middle of a line. It's not on a point, because it'll just make your work harder. Okay, so say I was to pick 2 points close together. So what I'm going to do is I'm going to pick this exact coordinate here and this exact coordinate here. Okay, what you do is you make a right angled triangle. I'm going to go from this upper point down the way. I always go down and then across when I'm making a right angle triangle, and I'd say it works just the same when we're dealing with a line with a negative gradient also. And I'm going to go across the way to make my right angle triangle there being the right angle. Okay, when we talk about vertical distance over horizontal distance, the vertical distance is given by this line here, this of course being the vertical line, and the distance is just given by, in this case, where we don't have an axis or anything of that nature, we just count the squares, so that is a distance of 2. The horizontal line is of course just a distance of 1 because it is 1 square. And then we use this formula, so gradient, G for short, is equal to vertical over horizontal, V and H for short, and we just substitute in our values. So this being the vertical distance and this being the horizontal distance. So it is just 2 over 1, 2 divided by 1, which is just 2. So this has a gradient of 2, and there's no unit that needs to go with that gradient. There's just a numerical value that tells us the steepness of the line. So this line has a gradient of 2. Okay. I'll do another example. This time we have to realize, and this is where you just need to be careful, this was a positive gradient. As you can see, the line goes up the page. This line is going the opposite direction down the page. Okay, so this is going to be a negative gradient, and it's just as easy when we're dealing with these types of questions because we're looking at the actual line to determine that. Pick 2 points on the line. Okay, I'm going to pick this one and I'm going to pick this one. Pick 2, they're nice and close together. Okay, I'm going to go down and then across first. So down the way and across. Right angle triangles to the right bit, doesn't really matter. There's the vertical distance and there's the horizontal distance, and that's 1 and that's also 1. Okay, so gradient, which is going to be minus, so we'll put a minus in front, is going to be equal to 1 over 1, 1 divided by 1, which is just 1, and of course it's a minus 1. But I do just want to take the opportunity, I did say earlier that it doesn't matter what 2 points you pick on the line as long as they're 2 exact points. If I was to pick the total opposite ends of the line, let's pick the furthest points away, and again just do vertical over horizontal. So if I was to go down from that C point there and across from D to make my right angle triangle, so there's a much larger right angle triangle, and I was to do vertical over horizontal for this line as well. There's the vertical distance, there's the horizontal distance. The vertical distance is 1, 2, 3, 4, 5. The horizontal distance is also 1, 2, 3, 4, 5. And of course the line's going down, so it's just negative. If you were to pick those 2 points, you would end up with minus 5 over 5. 5 divided by 5, which again is also 1 over 4 minus 1 because we're dealing with a negative gradient. So it doesn't matter what 2 points you pick in the line, just make sure you pick exact coordinates, alright? I'm going to do a third example here, and this is just something to keep an eye out for. So in this case, we'd be given an xy axis, okay? And again, it's the same sort of thing. We're going to do gradient is equal to vertical over horizontal, but just whenever you're dealing with a question that has an x and a y axis like this, always check the scales first, okay? Because the x-axis, as you'll see, goes up in ones. However, the y-axis goes up in twos. So that is misleading in the actual steepness of the line. If this was plotted on an axis where both of them were going up in the same values, this would actually be a steeper line than what it looks like on this particular axis. So just always check that. Pick any 2 points in the line. Again, I'm just going to pick this one and say this one. Vertical. And just always make sure you use a pencil and a ruler for this as well, of course, is equal to, so there's my vertical distance over my horizontal distance. Also, it is a positive gradient. So the vertical is this line here, but just being aware, because this is going 2, 4, 6, this is going up in twos, so each square going up the way is worth 2, so the vertical distance is equal to 4. However, for the horizontal distance, these are only going across the way in ones, so the horizontal distance is just 1, 2 squares. Okay, so then we substitute in our values. 4 over 2, 4 divided by 2, which is a gradient of 2. So just something to be careful of if you're dealing with an xy axis. Check the scales whenever you're working out the vertical and the horizontal distance. After that, the rest is the same. Just use the general formula for gradient is equal to vertical over horizontal. I will also show you how to do questions where we don't have a graph, where we're maybe given 2 coordinates and we have to work out the gradient of the line that will be given between those 2 coordinates, and we'll look at that in the next lesson. But in the meantime, have a practice and I'll go at some of the questions of this nature.